Oh. Now let's discuss about relative velocity. Relative velocity. We talked about combining velocity. You have two velocities are acted on the body. That is the velocity of the body and another body in nature, maybe air or wind or water, acting on that body that is already moving. So at the end of the day, we have to find the resultant of the velocities. But in this instance, we are talking about relative. What do we mean by relative? Relative means we are comparing positions of two things. Let me give you an example now. If a body A is, let's say P from O, and another body B is Q from O in the same direction, we will say that the distance of B from A will be B minus A, which is equal to Q minus P. Sorry, the distance of B from A, distance of B from A, not B minus A, distance of B from A is Q minus P. So that is what we mean by relative. That is, what is the position of one compared to the other. Just like when we are talking mainly about measurement, you talk about the base, the datum, that is the points, the reference points. So in this instance, the reference point is O, and the distance of B from O, we are measuring with reference to O. So when you are talking about velocities, you can talk about distance, position, and then that's when you can talk about change of distance with time, which is velocity. In this, for now, we are not talking about acceleration yet. We'll do that later. So I want us to have the pictorial view of this thing very well. Let's try to compare two bodies moving together. Let's say A is moving with velocity v, and B is moving with velocity v. If you look at the two of them, their position at every point in time will be equal to each other. The distance of B from A will be equal, especially when they are side by side. I've seen two different people in different vehicles moving, shaking hands. Why? Because their velocity is the same. So it will be like they are in the same vehicle. So when V and V are the same, you can see the relative velocity. Now, the relative velocity is 0. So it's just like their positions are still maintained compared to each other. But somebody outside, we still see them as moving. Let's look at another one. If A is moving, let's say O with V velocity, and the distance of A is P. Let's say B is moving with Q, and the position of B from O is Q, and it's also moving as with V velocity per second, meters per second. At every point in time, the distance of B from A will continuously be Q minus P, because the velocity is, they are moving, their change in position is equal in the same direction all through. That is one way to start looking at it. Now let's look at another one. If I like to use a figure now. Let's say A is moving with 4 meters per second. B moves with 7 meters per second, and they are moving in the same direction. Let's check what will be their distances from O after 3 seconds. After 3 seconds, A would have moved 12 meters. B would have moved 21 meters. Their relative position to each other will be 21 minus 12, which is equal to 9 meters. Just want you to see the relative velocity now. If you look at it now, you will see that for every second, the difference in their position is 33 meters. So in this instance, relative velocity will be equal to if you look at it, they are in the same direction. So relative velocity, when you are talking about relative, it is subtraction. So it is going to be 7 meters per second minus 4 meters per second. So with this, you can just easily say, after 3 seconds, their difference in position. You are taking one as the reference point. Now, that is what happens in relative motion. You take one point as the relative, one of the two moving bodies as the reference points, and then look at this. After 3 seconds, the distance between them is going to be 3 times 3. It is 9 meters. Look at that. Very easy. Now let them move in opposite directions. In opposite direction. Let's say A moves like this, 4 meters per second. B moves like this, 7 meters per second. Let's see the distance between them after 3 seconds. So this is the reference point O. So to the positive side now, A would move after 3 seconds. A will move 4 times 3, which is 12 meters. B will move 7 times 3, which is 21 meters. And if you look at the direction, it is opposite. So in this instance, we consider this one opposite. Can you see? We consider it opposite. So this one, in a normal mechanics or physics, the position, the vector is negative. Now, if you want to look at the distance between the two of them, you will say 12 minus 21, which is equal to 33 meters. Can you see now? Now, if you want to go by relative velocity now, the relative velocity is going to be 4 minus 7, which is equal to 11 meters per second. After 3 seconds, distance will be distance apart will be equal to 11 times 3, which is 33 meters per second. Please bear with me. It is going to be 33 meters per second. So distance apart after 3 seconds. Distance apart is equal to 11 times 3, 33 meters. You can see. So it makes our calculation very easy and straightforward. And there are so many things you can easily imagine. You see, this relative velocity is not something that you can pinpoint. This is the thing. But you can imagine it. And you can use it to solve seemingly big problem with ease. Let's look at another one. Let's see this situation. If A is here, let's call this place O, and B is here, and after measurement, we realize that the distance between A and B is 420 meters. Let's give A 7 meters per second and B 3 meters per second, and they have constant velocities, no acceleration. How long will it take A to catch up with B? It's very easy. Let's see. A distance covered by A is equal to 7 times t meters. Distance covered by B is equal to 3t meters. Now, we have seen that the distance between them is 420 meters. I want to calculate the time when this one will catch up with this. We will realize that 7t is equal to 3t plus 420, because that is the total distance they will meet at this place at time t. Let's call this place C. They meet at C at time t. Now, so time. We have 70 minus 3t is equal to 420. So 4t will equal to 420. C will equal to 420 over 4. That is 1057. So they will catch, they will meet after 105 seconds. Now let's see if we want to use the knowledge of relative velocity. The relative position between them is 420. 420. The relative position between them is 420. Now, relative velocity is equal to 7 minus 7 minus 3 is equal to 4 meters per second. So since they are in the same, they are going towards the same direction, we have 40 will be equal to 420. Just like what we got at last year. So T, if they meet up at T 420 over 4, which is 105 seconds. So there are so many things. Instead of going through this, for this place now it's easy. But there are some, it's not that easy. So, but when you use the knowledge of relative velocity, you get your answer with ease. Now let's look at situation where they come towards each other. So A is here, B is here. And now let's decide between A and B be 420 meters. And let A move with 7 meters per second and B with 3 meters per second. But towards A, which means that the velocity of B will be minus this time around. And they will meet at this place. Let's call this place G. So the distance, when the distance moved by A will be x, and the distance moved by B will be 420 minus x in that direction. So, but the distance will still be towards this direction. When you add the two, irrespective of the sense, will give you 420. Now, x will be 7t. That is the time at which they meet. 420 minus x, because it's towards this direction, is still 3t. Adding 1 and 2, I'm going to have 420 is equal to 10t. So t will be equal to 10 seconds, which means that they will meet at time 42 seconds. It means that t will be equal to 420 over 10, which is 42 seconds. Which means that the two of them will meet at this point at when the time is 42 seconds. We can also look at it again when we want to consider the relative velocity and relative distance. The relative distance is equal to 420 meters. You see, that's why we call it relative. You measure it from this point, from the other objects. From the other objects, either it is moving or stationary. It depends on what is happening. Now, the relative velocity is equal to 7 minus 3. Remember, it's in opposite direction. So the relative velocity is going to be 10 meters per second. So time of contact or meeting will be equal to 420 over 10, 42 seconds. Because it's on a straight line, this one is very easy. We look at another one now. In this one, we see it from from 2 dimensions. Let's say you have a point and 2 cars A and B. A moves like this, B moves like this. Let's say A moves in this direction with 15 meters per second, and B moves in this direction with 8 meters per second. You can see. What will be the distance between them after 3 seconds. The distance between them will be like this. This one would have moved 24 meters, and this one would have moved 45 meters. You can see. So the distance between them will be this. That's the distance between them. And because it is at right angles, this one is very easy. Just for example, we can say that the distance between them now is going to be this place and this place. Do you understand me now? This is the distance between the two of them. So how do we now calculate the distance between the two of them? We use Pythagoras, I mean, 15 squared and 45 squared plus 24 squared. Or that is how we'll do this one. Let me get it out. Now we can see. So it's going to be 51 meters. That is the distance between them. So in this instance, because it is vector, we always talk about b a the velocity of b relative to a, the velocity of a relative to b, the position of b relative to a, the position of a relative to b. Like in the other instance, I said a from b is 420. So if you want to check now, the position of b from a is 420 to the right, which is positive. So b, let's say b x a, that is the distance, will be equal to 420. For this one now, a, you can see, if you measure a from b now, it's going to be minus 420 meters because of the sense. Do you understand? Because of the sense. So this one is also applicable here now. So if you want to check what is the distance of b from a now, you must see it like this, and then you put this angle there. That is it. If you want to check the distance of a from b, you must put this angle there, and then you will say it is in this direction. Because it is in 2 dimensions, that's why it will be like that. So now let's look at it. Let's say I want to find what will be the distance of a from b after 3 seconds. Distance of a from b after 3 seconds. So this is a now, this is b. I have to say, okay, a is 51 meters from b, that is, and then the direction here, this is the direction, arctan 24 over 45. So that will give you the direction. That will give you the direction. So the distance of a from b is 51 meters in this direction up. But if the question is says what is the distance of b from a from b. Now let's see, for b from a, it is still 51 meters in this direction. So it will be arctan if you look at it, you will see. So it's going to be arctan, what's that? Minus 24 over minus 45. So that is b from a. That's how you get that one. Now, with this, we could have easily gotten this answer straight, just from relative velocity. Just from relative velocity. We have a like this, and b like this. A, that is 15 meters per second. B is 8 meters per second. So what is the difference in velocity of b from a? Just like we treated in vector, all you need to do is to move it in the opposite direction, because this will be minus b, which is equal to minus 8 meters per second in the opposite direction. So if I want to now find the velocity of b from A, I will tell you why we do that. It's going to be like this. It's going to be like this. So it's in the opposite direction. A, that is 15. B, that is 8. It has gone up. So we have this. And from calculation, we know that this is 17 meters per second. After 3 seconds, the distance between A and B will be equal to, that is A from B will now be equal to 17 times 3, which is 51 meters. In this direction, you can see the direction is the same now. 8 over 15, 24 over 45. You can see tan 24 over 45 is still the same thing if you cut it to 8 over 15. So relative velocity makes the subject very easy and it's still fun. It's fun. I'll show you another one now. Let's look at a situation. We have something like this. The position, this is A and this is B, straight line like this. And the distance between them is, let me say, 9. And A is now moving like this with 0.8 kilometers per hour. B is also moving like this, 0.8 kilometers, no, 0.6, yes, 0.6 kilometers per hour. What will be their distance after 10 hours? After 10 hours. What will be the distance of A from B after 10 hours? If you look at it, it's going to be like this. 9. A would have moved 8 kilometers to the right. B would have moved further down 6 kilometers. So which means from here to here we have 15 kilometers. This is very similar to what we treated in bearing. Remember, bearing. It's just like, let's just say bearing. That's it. Now, this is A and this is B. Just like what we did now. The distance of this place, of A from B, is 17 kilometers. Is 17 kilometers. And what is the direction? We got it. Now, the direction will be this. That's the direction. The direction is going to be tan 15 over 8. So A from B is 17 kilometers in the direction. That's 15 over 8. That is it. Now let us solve it from the knowledge of relative velocity. What is the relative velocity of these two? We have A like this. A 8 kilometers, 0.8 kilometers per hour. B, this is its normal velocity. That is the normal velocity for B. We have 0.6 kilometers per hour. That is the velocity for B. So, what is the relative velocity? That is VA minus VB. Which means that it will be like this. VB will now go up. You have to give it the opposite so that it will neutralize it. So this is VB. This is VA. And we have this one as 0.6 in the upper direction. And this one. So it's going to be this. (0.8 square plus 0.6 square. And what does that give us? it gives us 1. So, in this instance, what is it giving us? This is 1 kilometers per hour. What is the direction? Let's see the direction. The direction is arctan. So the direction is equal to 36.87 degrees. 36.87 degrees. Now, we can now calculate the distance from B. You know, initially, the distance was 9. That is the distance. So now, to have the final distance, we will now add this one in that direction. So we have it like this. 36.87. So this will now be the distance of A from B. This will now be the distance, the final distance, that one, of A from B. Because it was like this. Now, and what does this say? It says that we have made the motion of B stationary. That is what relative velocity is about. Relative velocity is saying one is made stationary while the other is made to move. We make one to look stationary and we move the other one. So the relative velocity is now what we are now dealing with. Let's look at what this distance will be compared to this one. This one is 1, Abi. We got 1. So after 10 hours, this place will be 10 kilometers. This place is still 9 kilometers. Let us now use our cosine rule to get this distance now. Please, I hope you are following. So this square is equal to 10 square plus 9 square minus, please, you know we had 90 plus this one, minus 2 times 10 times 9 times cos 126.87. So automatically this will be plus cos of this. So we have 100 plus 81 plus 2 times 10, 20 times 9, 180 plus 36.87. Let's see what that one gives us. So I have this. So this is equal to 289 and D will be equal to root of 289, which is equal to 17 kilometers. You can see. So when we talk about relative velocity, what we are saying is that make the other one look constant. That is, any motion this one is making, you are subtracting the velocity of the other one from it. You are subtracting the velocity of the other one from it. So you make one constant relative to the other one moving. So for calculation of relative velocity, it's just understanding of subtraction of vector. Let's look at one now. If a body is moving like this with a velocity, let's say 5 meters per second, another body is moving like this with velocity, let's say 2 meters per second, and the angle is, let's say, 25 degrees. It means that for me to find the relative velocity, every velocity of this one, I will subtract this one. And how do I subtract this one? You have treated that one in vectors before. You will move this one in opposite direction, parallel to this one, but with equal magnitude. So this is now minus 2 meters per second in this direction. Can you see? So for me to now find the relative velocity, it should just be like this. Just like when I was adding. So it means that I am adding with the negative of this one. You can see. So it means I am adding with the negative of this one. So it's going to be like this. 5 meters per second and 2 meters per second. So this will now be the difference. This will now be the difference. You know, this was 25. And this one now, what will it be? 180 minus 25. I believe that should be 155. So this place will be 155. So this is going to be 25. So this is the difference. But if I have decided to add before, it is going to be like this. 5, this is difference. And this one goes down like this. So this is the sum, resultant. So you just have to have that sense in your mind. That is all. It's very, very simple and fun. Just get that one in your mind, and every other thing you find very easy. When you look at it, especially when you look at it from vector form, you just look at it, oh, in the x or I or j direction, this is what it will be. In the y direction or j direction, this is what it will be. And then you resolve everything. You subtract, you add, and you get your answers. So I will use this time to go through some examples. Let's solve some examples. Now, what does this relative velocity really look like? Let's say, okay, I want to use parallelogram law to add two vectors. Let's say this is vector A, and this is vector B. And I want to add the two. You know, this is what I will do. I will draw, this will be VA, and this will be VB. And this will be VA, VB again. And this will be VA. Remember? So this will be the resultant. This will be the resultant. Please look at what I'm using as example. But if I want to subtract, I will draw VA like this, and I will draw the VB in this direction. You understand? I will draw the VB in this direction. So VA goes like this, VB will come down now. So this will be now be the relative. You get it now? So there are two diagonals in the parallelogram for the sum. So the other diagonal, when one diagonal represents the resultant, the other diagonal represents the relative. The other diagonal represents the relative. So if you are talking about velocity, velocity A plus velocity B, when VB goes up. But when VB comes down, you can see this is the relative, this will be the relative, this will be the resultant. Now, I just want to point that out so that when we are into the examples, you find it very easy to handle. Let's look at this simple one. Rain is falling vertically at 5 kilometers per hour. A man is traveling in a train whose velocity is 60 kilometers per hour. In what direction do the rain drops the windows of the train? Now, this is the velocity of the train. It is moving like this, 60 kilometers per hour. For the rainfall, it is moving down at 5 kilometers per hour. You know, if I want to sum, normally it will be like this. So this will be 60. This will be, what's it called? 5. But if I want to subtract, it will be like this. Now, so this will be 60. And this will be 5. So to complete it now, let me just draw like this. And then this is 5, this is 60. This is how it will appear to be dropping. This is how it will appear to be dropping. Because the train is moving like this and it is coming vertically. So this is how it will appear to be dropping to the person in the train. So it's going to be, let me make it like this. Arctan 5/60, or arctan 1 over 12. So that is the theta. That is the direction it will seem to be moving to the person in the train. So the answer is 4.76 degrees. So the person, it will be like it is falling at angle 4.76 degrees on the windows of the train. Let's look at another example now. Two aeroplanes are flying horizontally at the same height. Aeroplane A is flying due north at 200 kilometers per hour. Aeroplane B is flying at 300 kilometers per hour on a course 60 degrees. Find the relative velocity. Find the velocity of B relative to A. Find the velocity of B relative to A. Now, we have A 200 kilometers per hour in northward. B 300 kilometers per hour, 60 degrees. Now, to calculate the relative velocity, what do? We draw it like this. This is 300 kilometers per hour. And we draw, it's upward. 200. That's the subtraction. So, this will now be the difference, that is the subtraction of this from B. So this will be the resultant and the relative velocity now. This will now be the relative velocity. We knew what this was. This was 60 degrees and this one is down straight like this. So if you consider this one, you will see that this place is 60 degrees as well. And we can find this one using cosine rule. Let's quickly do that. Let's call this one VC. So VC squared is equal to 300 squared plus 200 squared minus 2. So 300 times 200 cos 60 degrees. Let's quickly work that out. So from my calculation, I can see that this VC, that is the relative velocity, is equal to 264.6 kilometers per hour. Now the direction of that relative velocity, that's what I'm trying to find now. And so, is equal to 200 sin 60 over 264.6. So let me quickly work that out. So, this is the direction now. This is the figure. So, in what direction will it move? You can see from here now. This was 60. So, it means that it will move down by 10.89 or 11 degrees. So, that is the direction of the relative velocity. So, it's like this. 60 plus, let's say, another 41. You can see that it's just 11 towards the southeast. So that is 11 degrees southeast. That is the direction of the relative velocity. So if you look at it now, you can see the direction of relative velocity now is 60 plus 41, 101. That is from here to here. Now, if we say, this is BVA, that is the relative velocity of A to B. Now, if it is from B to A now, it will be in the opposite direction, straight. The same value. It's just like you just move it 180 degrees to the other side. So, like this one now, it is 101. So, BVA. So, AVB will still be equal to, we still move like this, plus 180. But it will have opposite, what is it called? It will still be 264 0.6. That's what we mean. In the opposite direction. That is all. So you can do so many things with this, and it makes our answers easy to get. It makes our answers easy to get. You know, I said this is fun. Let's use vector analysis. For this b, let's say vb now. It is equal to, you can see this is 30 degrees. Are you? So we have 300 cos 30i, still in positive direction, plus 300 sine 30j. Let's see, what is VA? VA is in the positive direction, 200j. So VB minus VA will be equal to 300 cos 30i plus 300 sine 30 minus 200. Okay, so we have VB minus VA is equal to 300 cos 30i plus 300 sine 30 minus 200j. So this is going to give us 150 root 3 I, because this is so minus 50 j. Now let's find the magnitude. That is the magnitude. Will be equal to plus 50 squared. And what does that give us? Oh, root 3, please. Root 3. So that will give us. So you can see, it makes the working fun and very easy, straightforward. Now let's find the direction. We know what the direction will be. It means that it is like this, and our I is up. Our I direction is positive, and our J direction is negative. So it is going to be like this. So we have 150 root 3, and we have this piece as theta. So these are theta. Let's find the theta now. So the answer for theta now is 10.89, approximately 11 degrees towards the downward direction. So if you want to really look at it, we say it is going to be, so direction for the relative velocity will be equal to 11 plus 90, which is equal to 101 degrees. Just like before. You can see that this vector form makes it very easy and straightforward. Just like ordinary addition, and you get your answer without drawing.